Good morning, students. Today we are going to discuss in detail about addressing modes. What is an addressing mode is in the instruction, in what way we are giving the data, whether we are giving from the memory or we are giving from the variable, through the variable or through the input device. The method of giving the data, that is called as an addressing mode. Generally, it is called, there are various 5 types of addressing modes. Here, first addressing mode is called as immediate addressing. From the name you understand that immediate means we are giving the physical address directly along with the instruction. Here the general format is opcode, and RS stands for the source register and the target register, and the immediate address we are giving. OP stands for opcode. Opcode is represented by 6 bits, and the source register is represented by 5 bits, and the target register is represented by 5 bits, and the immediate address is given by the 16 bits. So totally we are having 32 bits to represent an instruction. Here in the example we are having add I. Add stands for add immediately. Add I. The content that is available in S0 and S2 are added, and the result is stored in S2. So this is an example for immediate addressing mode. In the immediate addressing mode, we are giving the address directly. The data is added in the source register. This is called as immediate addressing mode. Next addressing mode is the second type. The second type is called as register addressing mode. So in the register addressing mode, we are having the source register, target register, and the destination register. Here the result is also stored again in the target register. There in the immediate mode, we are storing the answer in the memory. Here we are storing in the destination register. So source operand 1, source operand 2 are taken here from RS and RST. Then the result is stored in the destination register. Here we are having the shift amount is represented as 5 bits. Whether we want to shift to the left side or right side, due to the presentation we require the shift amount, and what is the name of the function we are having. Function is generally here represented as add and subtract. Add is having the function count as 32, and subtract is having the value as 34. So here add $S2, $S3, and $S1. That means here the content of S2 and S3 are added, and the result is stored in the destination register. Here the shift field is represented as 0, and the function, the opcode for the function add is 32. So here addition is happening in the register addressing mode. Next addressing mode is after the immediate addressing, register addressing. Third one is called as actually base register indirect addressing displacement address mode. Here in this example, LW $S1 $32 $S3. What is the function of this instruction is, this instruction loads a word from the memory, main memory location, into the destination register. So it is used for loading the word. LW stands for load word. The opcode is 6 bit. Here the source and the destination register we are having. From the address it is taken and stored in the register. So this is added with the value that is available inside the register. Here the memory content is byte, half word, or word. Every word is represented by a 8-bit data. Here half word represents a 4-bit. So they are taken from the memory and stored in the register. So it is a data transfer instruction. Simply we are transferring from the memory to another register. So this type of addressing mode is called as base or indirect addressing or displacement addressing. Then the fourth type is called as PC relative addressing. PC means what? A program counter. What is the function of the program counter is it contains the address of the next instruction to be executed. Now, in the addressing mode, the address is stored in the PC itself, the program counter itself. The program counter relative addressing mode. Here, the example is branch not equal. BNE stands for branch not equal $S0, $S1, 100. Here, what is done here is the 4 is a displacement field, 4 bytes. It is added with the PC because to fetch every instruction you require 4 bit to be added to fetch the next instruction. Always the program counter pointer is stored here by 4 bits. From the 100, the data is multiplied by 4 because 4 bytes. 100 into 4 is 400. 400 is actually, it goes to 400. Branch not equal, actually the address you have to move is 400. So plus 4 is added here. So the source content is moved to the constant 100 is given here. The source content is moved to the 400 location. So this is relative addressing mode. Branch not equal $S0, $S1, comma 100. This is the fourth addressing mode, and the fifth addressing mode is called as pseudo direct addressing mode. This is the last type here we are having. It is actually followed by the jump instruction, where the program control shift from the main program to the next program. Here jump 2500. Jump 2500 means the physical address, the 2500, the pointer, the program counter is the pointer, it moves to the 2500. So here it is multiplied always by 4, because every program counter is comprising of 4 bytes we have told. So into 4 we are taking, so it moves to the jump address as 10,000. So the target address is 10,000, but the specified address is 2,400. It is multiplied by 4 because every half word we are saying. So the program counter shift to the 10,000 address. So from the current location, it jumps to the 10,000 address. So this is one type of addressing mode called as a pseudo addressing. So totally we are having 5 types of addressing mode: immediate addressing mode, register addressing mode, then indirect addressing mode, PC relative addressing mode, and the last one is called as pseudo direct addressing mode. With the help of the diagram, how the bits are transferred from the memory to the register, it is stored with the help of a program counter. So this is called as addressing mode, the topic addressing mode. Thank you. We will discuss in the next class.